Well, thank you all for joining. This has been a session that I've been proud to present for quite a few years because I'm so passionate about MPLS. The reason I am passionate about MPLS is because it was one of my absolute worst topics to learn when I was studying for all these different certifications, and we didn't have a way to practice it. So when you're out there trying to figure out MPLS, you don't have a way to practice, it got to be kind of confusing, and it wasn't exactly the best. So we put together this session, I don't know how many years ago now, and I just kind of kept going with it because I found that the certification industry really needed it because all the customers are still running MPLS, and so are the service providers. And then you find out that a lot more customers are actually doing this in practice in large enterprises as well. So I try to make this to the point where we step through it in a way that's going to be kind of simple and easy to follow. So hopefully this is good for everybody here, and if anybody has any questions, please feel free to just shout out or raise your hand and let me know, and I'll repeat it and we'll cover it. Again, my good friend Dustin Schumann here, who's on the council for us to kind of show us what all the command line stuff is going to look like. I really do appreciate him being here. Again, he's a co-author of that SD-WAN book that came out a couple years ago, a few years ago, 2 years ago, two years. And he's actually working on a second edition for that book now. So I'm super proud and happy to have Dustin here with me in my corner yet again. So what we're going to cover today is the introduction to virtualization. And when I say that, it's going to be how we're talking about the network virtualization. And that doesn't necessarily mean we're virtualizing like routers and stuff like that and firewalls, but we'll talk about what that means. VRF Lite is a big common topic that when we typically see it taught, that it's kind of confusing. And I want to try to take all that confusion out of it, so when we talk about what a VRF is and what VRF Lite is, that it's not as difficult to consume as you might think. And when you want to add routing to it, there's potentially 1 to 2 commands that you have to do to add it. And we'll talk about why that is so important in the MPLS scheme of things here in a little bit. Then we're going to cover something called MPLS, or multi-protocol label switching, which is probably some of the biggest reasons a lot of you are here. And there's something called the BGP free core we're going to dive into. So for the folks, I talked to a couple folks who are service providers and some other folks who want to run this stuff internally in their environment, what that all really means. And then finally, the control plane that controls all of this and the VRFs and all of these different things that you're going to see is run by multi-protocol BGP. So what we try to do is really step you through the whole story of how to get started in small chunks and take it all the way through a fully functional MPLS network and watch as on the screen we can see how we troubleshoot certain things, we look at all the different outputs, and we can kind of learn together in a journey. And then finally, we'll conclude with a couple things that I'm going to talk about where I mentioned to some of you folks that there are some pieces that are important if you're taking an exam, and there are some pieces that are important if you're doing this in production. And some of them are very similar, but there are things to keep in mind in the different scenarios of what you may be doing, because in exams, they're trying to trick you to see if you know some of these options. So that being said, there is a WebEx app if you want to join the room. I think automatically everybody who's a participant who registered for this gets put in this room, and I'm pretty sure it stays on until February 23rd, so you can chat with us and ask any kind of questions, or if you want any kind of just feedback, I can give you that, and it'll be available for pretty much the rest of the month. Now, I'm going to give you a brief, I'm spending a second on who I am and what I do and why I think this stuff is so important, and that is a mouthful, right? I'm a technical evangelist for the worldwide enterprise networking software and sales team. And I think that if you can get through the name of that title, you'll be able to get through this session with absolutely no problem whatsoever, right? Because that just seems very complicated. I've been fortunate and blessed enough to write quite a few books for Cisco Press and be involved in a learning community for quite a lot of years. I was developing CCIE exams before I ever even joined Cisco. And I had a great long-standing partnership with Learning at Cisco, and that kind of spawned into a whole bunch of different things as far as writing books. And I was fortunate and blessed to be part of the first programming and automation book that Cisco ever released for Cisco Press, which was this Programming and Automating Cisco Networks. From there, I have gone through a whole bunch of different things to try to help the certification community, as well as folks who are delivering these different things in their environments. So my day job, not only do I get to talk about all of these cool things with customers all over the world, I actually help build all the training content and curriculum for our field to go out and deliver on any enterprise networking software, or hardware for that matter. So I'm kind of a teacher by nature at work and outside of work. And so that all being said, one of the things that I want to call out on this slide, there's two things. One, that Dustin Schumann also helped me write this book for software-defined WAN, and there's a second edition coming out. But also, if you look at the CCNP and CCIE core book, as well as the second edition that just got dropped here in October, this stuff is talked about briefly, and it's important when you need to go for one of these certifications. The other book I would recommend that is not on here is written by Brad Edgeworth, who's another buddy of mine I've written a bunch of stuff with. There's an iOS XR, I think it's Fundamentals, or yep, book where it's more of a service provider operating system, but the explanation on MPLS is actually really, really good, and it doesn't hurt to pick that book up too, right? Either in Safari or in physical form. So that all being said, I am transitioning to do a couple other things here pretty soon that are going to be published at some point here in the near future that we can't talk about, so I will just leave it like that, and we'll continue on to the next slide. So, how many of you folks in here know what this is? How many folks have ever seen these used in a restaurant or in a bar where they're dispensing drinks, right? Why do I bring this up? For a couple reasons. A couple reasons I bring this up. I'm going to hand this over here. I'm going to have you pass this around so everybody can kind of just get their hands on this and look at it. And then I was sitting at a restaurant one day, and I'm watching this thing do its job. And I was like, you know, that's pretty interesting how that separates all the different flavors, and it doesn't destroy your drink, right? It doesn't sound like you mixed everything together, and it kind of segments all the different flavors, right? I thought, hey, that's pretty slick. And I said, well, I wonder how that works. So I dove into it a little bit, and I came up with this idea of what's a VRF, right? VRF is just a separate lane on the highway for traffic. Think this could be a .1Q trunk, and every one of these could be a VLAN. And you mind if I throw this to you? The reason I think this is so important to understand is you'll know if some of those wires are crossed or if some of those hoses are crossed by drinking whatever it is you're going to drink, and I think everybody in here can identify with what that would be like. So when we talk about a VRF, it's no different. Think about a VLAN, layer 2. VRF is just a layer 3 segment. It's essentially another logical separation of your router to be a whole nother logical router. So when we start talking about this, this is where what this whole virtualization thing comes into play, where we're taking things like a VLAN, layer 2, right? But now when we take a VRF and we cut it in half, and we take your global routing table and we add another lane on the highway, that's a totally separate partition in your network for whatever type of traffic you want it to be. Just like any other router, the second you do that, there's some things that you have to consider doing. You're going to need to be a separate routing table. Everything you do when you start looking at monitoring and troubleshooting, ping, traceroute, is going to be in that separate routing table, which is a separate VRF. So when you go through that, you have to make sure you call out ping, VRF, VRF name, and whatever IP address, right? Because you just separated from the global routing table, and if you don't do that, you'll start seeing a bunch of dots, and you're like, well, I wonder why nothing's going through. Because you're trying to ping something in the global routing table, and the route doesn't exist there. So when we start talking about these things, it's really cool to look at how they differentiate themselves from layer 2. So over here, we have something called layer 2 forwarding, which we're all familiar with, I'm sure, but there's layer 2 interfaces on a switch. They all have their own MAC forwarding tables. They all have their own difference of spanning tree instances for VLAN. You have all of this information. When you interconnect them, it's typically done by a physical cable, which is a .1Q trunk, where just like that thing that we're passing around, and it has multiple VLANs that carries over it. When we look at layer 3, and we're talking about VRF forwarding, there's a whole bunch of different things that happen. Every interface can have its own VRF associated to it, right? As we probably know. Multiple interfaces, you can do that. At the same time, when you do that, it has its own Cisco Express forwarding table associated to it. And then when you do that, you have to have your own separate routing process. And this is where I think it gets to be really important when we're talking about routing. If you're familiar with any routing protocol, I mentioned earlier, there may be 1 to 2 commands that you have to add to enable routing for a VRF. That's what VRF-aware routing is called. We've heard of this a couple times, VRF-aware routing. It's the exact same thing. You're just putting 1 or 2 extra commands in it to tell it what VRF it's in. But every other thing you already know about routing, It's the same, which is really nice because if you've been doing this for a while, you're not trying to learn a whole bunch of new things, and that's why I try to step everybody along on this journey. How do we interconnect VRF Lite? Trunks, just like we said, GRE tunnels are an option, right? You can do a point-to-point GRE tunnel and have separate VRF running over it to segment that traffic just over a tunnel if you wanted to. Real easy to fire up, real easy to segment. The other thing that's important about this is you could even separate physical cables, physical interfaces. All these things could be in their own separate logical virtual router. Production, or your test, whatever it may be, can all be segmented using a VRF. So when we talk about that, that's what path isolation means. We're talking about taking a path between one device and another and separating the traffic completely like it's a separate logical lane on the highway, and you can just continue to send your data back and forth on that particular path. So when you're looking at things like this, the thing that I really try to call out is that you're virtualizing your control plane, which is what's handling the directions of where you want to send that traffic. You're also virtualizing the data plane, which means I'm taking my data completely out of the global routing table and it's completely segmented, one department from another. But think about it from a service provider perspective. You have multiple customers, most of which are all running the same private 1918 addresses. We can't have them in the same VRF because it's not going to route, it's not going to work. So it separates the data plane too. And any kind of other services you might have on it, multicast, whatever it may be, would run in that separate lane on the highway. Now, as far as the path, what I like to call out is when you're using VRF Lite, and we're going to get into that in the very next slide, it's just like .1Q trunking. So if you have a transparent switch and you have your VLANs on it, every hop, you have to make sure that that VLAN is allowed on that trunk. Because if you don't have end-to-end reachability. Exact same thing. Every hop in that chain has to be in its own VRF. Whether it's static routed or running a dynamic routing protocol, you have to do that. If you miss a step, you're not going to have end-to-end reachability. Now, when we're talking about this, all kinds of different things are ways of isolating a path or changing a path, right? You can have multi-hop with VRF Lite going over the top of a GRE tunnel. Cool. Using MPLS VRFs and VPNs is what you typically would see if you're connecting to a service provider or you are a service provider. You can have VPN over IP. You can do anything you want. DMVPN, remember IWAN? Does anybody in here remember IWAN? Right? The idea is you're running DMVPN in a separate VRF just to segment that traffic. So no matter what you're doing, it's very similar to probably what you already know and are doing today. So when we dive into VRF Lite, it becomes easier to understand. And the reason I talk about this is VRF Lite has been, I've seen over the years, a lot of folks describe it and really, really overcomplicate it, as well as sometimes they make you think that you might have to have certain pieces like MPLS labels, like multi-protocol BGP, and you don't. You just make your separate logical lane on the highway, and then however you want that traffic to go back and forth, it could be a static route, it could be a dynamic route. You do not need any of those other things to do VRF Lite. And this is good for a couple places and a couple reasons, right? If you want to do something, and for everybody, please don't freak out because you see the words frame relay on here. There's a reason I left it in, but it is on no exam, so don't worry about it. But there are still a lot of customers in 2024 running frame relay. That is no kidding, all right? So I put that on there so you can understand there's a couple different things, right? You could do the trunking, the frame relay, any routing protocol you have can be VRF aware based on just saying, oh, I'm going to add this particular command or two. Layer 3 interfaces can only belong to a single VRF, which means you can have separate VRS for every interface, but you can't have one interface in two, right? Which is common, right? So there's some things to remember. Just like I mentioned with the layer 2 .1Q trunk, if you don't do this on every hop, you're going to have some reachability issues. The other thing is that you do not need multi-protocol BGP for any VRF Lite. You do not need MPLS. You do not need LDP. You do not need labels. You need none of it. However, the linchpin here, and the thing that causes some heartburn, is just like transparent mode VTP, if you have 6 switches and you just need to add a VLAN to 6 switches and hop across 6 different switches to add it across the trunk, it's easy. It's not that bad. If you have 26,000 switches, that's a problem, right? because then you're doing a whole lot of things and now we have automation a lot of the times today, right? Or tools that'll do this for you. But if you're manually doing that, that is a very big deployment. Similarly with this, if you have a small amount of VRFs or small amount of networks, it's not bad to have a couple VRF Lite interfaces because you can maintain it. But when you get to be a global network that has hundreds, if not thousands of nodes or sites or locations, that gets to be really hard to control because you're going to have to configure that on every single thing. And of course, we all know as network engineers and network operators that nobody ever just walks up behind you and says, hey, you know what would be really awesome? I want you to spin up a whole brand new VRF for test lab. And I want it to be across every location. Well, now what do you got to do? You have to touch every single one of these sites multiple times over. And then you have to make sure your routing's set up. It becomes a nightmare. But there is definitely a use case for VRF Lite. So here is the topology that we kind of have in the lab in the back end. So what I will say is this back end is running on dCloud, which is our demo cloud that we have, and we have access to this. And if you don't have access to this, I think we can just reach out to your account team and they can actually spin up this lab for you if we have to, okay? If you look at this, you'll see we're just going to have a couple separate interfaces that have different VLANs. They're going to have different IP addresses and different loopbacks. Pretty straightforward, simple topology. And I kept it that way for a reason. When we're talking about the different VRFs, there's one called R for RIP, and again, I know a lot of people are like, RIP? There are still customers running RIP, all right? And I will say, friends don't let friends run RIP, but it's still there. And my REO Speedwagon joke wouldn't have worked if I didn't put RIP. So VRFE is EIGRP, and OSPF is O. So that all being said, how do we even configure sub-interfaces, and how do we configure VRF Lite? If you look at this, you could start off by saying IP VRF and a VRF name. Now, we're going to talk about the fact that there are multiple ways to configure a VRF. We're saying IP right now, currently, because a majority of folks are running IP version 4, right? And we're going to talk about this VRF definition thing in the next slide so we can talk about how we can change multiple address families. But if you say IP VRF, VRFR, and then you come up and you put in sub-interface, and just say IP VRF forwarding and that VRF name, you literally just took that interface and ripped it out of the global routing table and stuck it in its own lane in a highway. That one command does that. Now, what we will also caution you for in practice, in production, and in any kind of certification is if you do that and there's an IP address configured on that interface, it will automatically wipe that IP address off of the interface because you took it out of the global and it says, I don't know where it needs to go. So the second you say IP VRF forwarding, you've lost that IP. So you have to retype it in. I will also tell you that if you're going for any kind of certification, maybe in the CCIE kind of realm, that you'll get in there into a lab exam, potentially, and there'll be no start configuration. So if you do that, and you didn't do a show run, or you didn't look at the interface before you did that, you will not know what IP address you're supposed to put back onto that interface, and you will definitely lose some points, if not blow up your entire lab. So there's a reason we say that. Also in production, you can blow up your whole network. But the idea here is it's all the same. So we're just going to configure these different sub-interfaces for each routing protocol, and then we're going to forward that information onto it so we can separate those logical lanes on a highway. Now, I'm seeing more and more folks going IPv6. Anybody in here using IPv6 in your environment today? Okay, a lot more than it was in the last time I had this conversation, right? It's important because we're all transitioning to this whole new way of doing things. If you look up here, there's something that says VRF definition, and it's very similar, VRF-R, it's the same thing. But when you say VRF definition, you're not specifying IP, which means you can pick if you want IPv4 or IPv6. So then the next thing you'll see is you could say VRF forwarding, that particular VRF name, and it looks pretty good, right? So what happens when you want to do, I don't know, IP version 4? You have to specify the address family by saying address family IPv4 or address family IPv6. Now by doing that, that's when you're assigning whatever type of IP space that you want on that particular VRF. You can dual stack. There's all kinds of different things you can do with this to get super complicated, but that's how you would pick if you want to use IPv6 or IP version 4. And I know my friend Nicole would be very, very happy to hear me talking about IP version 6 for anybody out there who knows Nicole Weyer. So let's look at the command. Let's look at a couple things. If you look at this, there's a command out there, so a lot of folks that I talk to who are running MPLS or wanting to run MPLS are traditionally doing version 4. And so which means they have the IP space, whatever command in there, right? You can actually run this command that will upgrade the CLI to multi-address family mode, and it's just a parser. So it'll just reconfigure it all to put it into that VRF definition mode automatically for you without you having to reconfigure anything. And the last multiple times I've tried this, it's hitless. It just changes the syntax of what's in the running configuration, right? Because all you're doing is changing the way that the words are written in the config file. That also enables you to say it will do address family IP version 4 automatically for you since you had IP, VRF, and VRF forwarding. Now, when you look at that bottom configuration, you can see very similar. You can say, here's VRF forwarding. Then you put the IP address on there because of what we talked about. It'll erase it. And then you just say VRF definition. And then you see this thing that says RD, which is route distinguisher. And we're going to cover that a little bit later on. The odd thing about this, and you're all looking at me like, wait a minute, you said VRF Lite doesn't need all this stuff, right? For some reason or another in the iOS, you still have to put an RD in that particular configuration. And then route target, in this particular case, is for if you're running MPLS and you want to actually exchange routes between different areas of the router. We'll talk about that when we get to it. But the minimum, you have to type in RD. It's foolish. I have no idea why that they kept it that way. It doesn't even use it. Not until you get into the further conversations of what we're about to get into. So let's take a look at RIP for the folks out there who are still running RIP. Don't run RIP, okay? But the idea is, from a simplicity perspective, all we're doing, as I said, is going to be adding maybe 1 to 2 commands. If you look at this, RIP is how it was before. The only thing different here is address family, IPv4, VRF, and the VRF name. And then all your RIP configuration goes underneath it. It's exactly the same. You've added 1 command because you ripped it out of the global routing table, which would be right above that, and you put it into a separate lane on the highway by saying this command. And then everything else looks exactly the same. So you get to leverage the information you already know on any routing protocol. Let's take a look at EIGRP, right? We're all familiar with EIGRP. It's the best in the world. Cisco made it. It's awesome. Okay. Maybe I might get paid for that. I don't know. But if you look, this is the one where it gets a little bit different. I said 1 or 2 commands. EIGRP being internal, we had to add a couple things to it, right? So we said address family, IPv4 VRF, VRF name. Same command as RIP. It's awesome. But because you just ripped it out of the global routing table and you made a separate lane on the highway, you have to specify an autonomous system number for that lane, otherwise you'll never peer with your neighbor. And what makes it even further odd, they could be the same for the global and one of the sub-address families. So it could say 10 and 10, and it's fine, which is weird because one's for the global routing table and one is for that VRF. So I specifically show that they match for a reason. Because a lot of times you'll get in an exam and he's matching, like it can't be in that because that's the global one, and it's just there to mess with your mind. Whatever the global one is, doesn't matter if it's 65.535, it doesn't matter. It can be anything you want. The one underneath that says autonomous system number, that is the one that matters for that separate lane, right? Then OSPF, the standard. So when we talk about OSPF, it's just a little bit different yet again because it's a standard protocol. So if you look at it, router OSPF 1, typical how you would normally configure it, but with the new way, router OSPF, process ID, VRF, and the VRF name. And then everything else is identical, right? So does anybody have any questions on what we just talked about and how you would differ from a VRF to making it VRF aware routed versus what we typically do with just typical routing protocols? Are there any questions out there? Good, tracking? Awesome. So we're going to dump right into the command line, as you could probably see already. And what we're going to do is we're going to run all these commands because it's all pre-configured. This is everything we just showed is configured, and we're going to show you what this all looks like. And of course, I don't know if I have a laser. Is there a laser? Oh, there's a laser. I have a laser. This is awesome. So if you look at this, these are the sub-interfaces we were talking about that have the IP addresses, right? Right now, they're just typical sub-interfaces that have IP addresses associated to them and a loopback IP address, too, at the bottom. no big deal. Looks like everything you've normally done, show IP interface brief, super easy. Where things start to differ is when we start talking about calling out the VRFs. Now, there's a command here that says section that says I'm going to include anything that says VRF in it. If you look, you have IP VRF. I clicked the wrong button here. Let me slip back. You have IP VRF B, which we are going to be talking about for BGP, EIGRP, OSPF, RIP, and static. And there's that RD. Again, that has to exist for that particular use case. But then if you keep scrolling down and we start looking at some of these other things, here's what the subinterface full configuration looks like. A typical subinterface with the .1Q trunk type of configuration that you're used to doesn't change. The only thing you do is you add that IP VRF forwarding VRF-R. If it was multi-address family, it would be VRF forwarding, whatever the address family is and all of that, right? It's the same thing. You can just throw it over here on the floor. It'd be great. Thank you so much. And then as long as that other one comes back too, TSA won't try to tackle me when I just bring this. So that being said, when you're looking at these things, it doesn't matter what operating system, or I'm sorry, what type of routing protocol you do, it's the same. Now, this is another cool trick. Show IP VRF interface. So very much like show IP interface brief, but you could see the IP address, what interface, and what VRF it's associated to with a real easy command. None of this is MPLS. None of this is multi-protocol BGP. This is just layer 3 logical segmentation on your network using the routing protocols that you're already familiar with, right? So he's going to launch another script here real quick, and we're going to talk about what the subinterface kind of routing in this looks like. So as this goes, we have a whole bunch of stuff. It dumps it all out so we can scroll up and look and down and show you. But if we come up here to the top, we'll notice a couple things from the router perspective right here. So I keep flipping these slides, and I'm so sorry. Router EIGRP 10, just like we showed in the snippet, running with an address family of IPv4 VRF-E, all your network configuration that you normally put, and your autonomous system number. This is actually running on a router, right? It's working in this particular case, running exactly what we showed. All you do is make sure that you call out the VRF and make sure that you have a separate autonomous system number, otherwise you're going to be in trouble and you won't be able to talk to your neighbor. So that also being said, here's our OSPF standard. This is actually running right now. There's an OSPF process running this that has these things separated out by the different IP addresses and, of course, the VRF itself. Now, right here underneath it, we see OSPF 1. We're going to get into the MPLS core network here in just a few minutes and why that's important. OSPF 1, this particular instance of OSPF, is running just to advertise the edge router loopback IPs through the core so you can run that multi-protocol BGP over the top of it. And we'll get into that in a bit. But that's why there's two OSPFs. One is literally for the global routing table, just for the loopbacks. The other one is going to be for your specific VRF. Same with RIP. Again, we don't really like RIP, but RIP is here, and it still exists out there, which is interesting. But it does exist. Same thing. And now BGP, though. A lot of folks asked about BGP because it's a little bit different. Well, what do I do with BGP to make it VRF aware? Wouldn't you know it's the exact same command that you would do for RIP and EIGRP? It's the same thing. Address family IPv4 VRF, and then you put in whatever different type of thing you want to have for your routing. Now, that being said, you'll start to see some stuff down here that says activate. When we start talking about the different address families for VRF routing, for MPLS and multi-protocol BGP, when you do this and you create these core different types of networks, you're not going to be using the global routing table. So you have to specify certain things to make sure that you're using the right section of BGP and activate the different address families. So IPv4 routing in a service provider network doesn't happen because all their customers are running 10.1. Whatever, right? You can't have IPv4 running because everybody else is doing it. So that's when you have a separate VRF and you're using something called VPN v4 routing, which is a separate address family that just exchanges a lot of this information. So that's what that means. Now, one last thing we're due down here at the bottom, we see that we say show IP EIGRP, but we have to specify VRF in the VRF name to do any show commands, any monitoring, any trace routes, any pings, because otherwise you're doing it in the global routing table, right? So even with OSPF, I think is right underneath it, right? So OSPF, the same thing. Show IP OSPF in an interface brief, but you'll see a couple things. PID1 means this is the global core, and PID2 is the VRF-aware router version of it. It's just for VRF Lite. That all being said, we'll show VRF neighbors, or I'm sorry, OSPF neighbors right here. You can see the different routers, all that, everything else is exactly the same. We could show RIP, I guess it's right there. You know the routing table has all these different things in it when we're looking at the different VRF. So we're picking on the VRF routing table, show IP route, VRF name. Similarly, EIGRP, same thing. Now you have to know that when you call out these commands, if you're in a lab exam especially, and you just do show IP route, and you start getting that panic mode because you're not seeing what you're supposed to be seeing, it's because you're in the wrong routing table. So that being said, I think we can flip back, or we got more script? We got one more script? What are we going to surprise them with today? Oh, we're going to actually prove that it works?
Yes.
Oh, we got to prove that it works. Same thing, ping, right? He's going to run these. Ping VRF, VRF name, and wherever you're sourcing it from. This is another thing that's important. If you do not advertise your interface, your directly connected interface links into that particular routing table, you have to source it from a specific interface. If you do, it could just automatically go through because it takes the interface as the source, right? But we don't have it set up that way, so you know that you have to source it from a loopback because we're routing from loopback to loopback through that topology that we showed on the previous slide. Any questions with anything that we just talked about? Just wanted to see if there's any questions. We're all tracking along. Everybody's good so far? Awesome. So let's take a look at this next situation. Say you don't have a sub interface. This is very possible. A lot of times you don't have that capability to do it. You could use GRE, same topology, everything it looks exactly the same. You would just use GRE over the top and still be able to use VRF Lite to segment your network. How do you do it? In this case, we're going to pick on static routing, right? IP VRF, VRF name. In this case, we call it S because it's static. We have to call out some sort of RD. It could be whatever you want it to be, but we have to call it out. We pick a loopback, we put it in the global routing table, we then say we have a tunnel interface, and we want to establish that we're going to put that tunnel interface in that VRF that we just created, that separate logical lane on the highway. Then, of course, we put the address afterwards because it'll remove it. And then we're going to say the tunnel source is from this loopback, and the destination is going to be to the far side. And here's the far side configuration. It's the exact same thing. The only difference between a GRE tunnel and a GRE tunnel running MPLS, or I'm sorry, VRF Lite, is that line that says IP VRF forwarding. It's the only difference. So if you, in a pinch, need to separate something across locations or across the same location, well, however you want to do it, you can actually use a GRE tunnel real quick to segment some traffic. So let's take a look at this. Another scenario. Again, remember, don't run out of here because I say frame relay. But if you don't have a serial link, right? Say you want to do something on your own, you can do back-to-back frame relay between multiple different devices, and every time you have an interface with a DELC on it, or what is it? Data link control, man, it's been 15 years since I talked about frame relay. So a DELC is your logical identifier on those sub-interfaces to map it to your frame relay switch or whatever you're doing on the other side, right? The thing here is when you look at it, and you look at how it's actually configured, it's pretty much the same thing, right? We have an interface, we're encapsulating it to frame relay, but we're not using a frame relay switch. So we're not importing any kind of DELCs from that frame relay switch. We're doing it back to back. So it's just between two different routers. Could be across different, it could be a point-to-point link, it could be across different departments. But what you notice is you have this point-to-point link. In this case, we're going to pick on BGP. The reason there's a word that says no keep alive here is because it nails up that tunnel, because it's otherwise going to be waiting for a frame relay switch to tell it, hey, are you live? Are you live? Are you live? And if you're trying to do this, there's no frame relay switch, so you have to tell it not to do that. So if you look, we just say IP VRF forwarding, VRFB, and we call out the DELC that is mapping to that particular thing. If you look at the other side, it's that same thing in the reverse order. So just like that, we're going to dive into the command line and show how these actually work. Now, what I want you to keep in mind is the reason I'm showing you things like frame relay and some of these other GRE examples are a lot of folks still in production use them, for one, and you could be one of them, and I'm not making fun of you if you are. But secondly, a lot of times you go into some exams where they'll have some of this stuff configured for you. Maybe not frame relay so much because it's not in any exams anymore, but GRE definitely is. And when you're talking about all these different ways of doing segmentation, this is definitely one of the things that pops up in certain exams that you have to configure. Now, here it is. It's configured. It's live. IP VRF forwarding, VRFS for a static route, IP address that we have to make sure that we didn't lose it, the tunnel source and a tunnel destination. And we're going to look at the other side here as we go down here just a little bit. But we're also going to see that we've configured this. How do we make sure that it actually works across both of these different things? So if you scroll down, you're going to see VRFS a little bit further. And the biggest thing is this bottom line right here. Static route is technically a routing protocol. I know people don't think about it that way, but you can do all kinds of different manipulations just like you would with a dynamic routing protocol in a static route. VRFs, MPLS, there's a million different things you can do with it. So you would say IP route, VRF, the VRF name, and then you would put that static route in. And once you do that, you're going to have to make sure that there's one on the other side pointing back in the same direction. Otherwise, you're not going to be able to have full reachability, just like you would expect. So that being said, let's look at this here. Here's a routing table. Show IP route, VRF, VRFS is just up a little bit further. And a little bit further. And, oh, it's up here a little. There it is. Show IP route, VRF, VRFS shows the routing table for that particular VRF, and you will see the static route in it. If we scroll down just a little bit further, right here is that static route in a VRF. So now you have VRF-aware static routing, VRF-aware dynamic routing, and now we're going to prove that it will actually work by running a couple pings. And there we go. So this is running. This is all running right now. You can do this in any different type of lab. You can do it in production. It's really neat. It's fun to do because you can have all kinds of different methods of getting around things. And the reason I call that out is because sometimes you need something as a patch in production, and sometimes you need a workaround in a lab exam to get certain reachability up, right? Now, if we go back to the slides real quick, I'm going to show something while he's doing this. So, VRF Lite. You create a VRF on a router, and it creates its own routing information base and forwarding information base. Separate logical lane on the highway, right? Totally separate. That's virtualization in its own self, right? Now, I know virtualization nowadays could be servers, could be networks, could be a whole bunch of different things, but this at the most simplest form is you just virtualize another router within a router, right? So everything applies to that. You don't need MPLS, you don't need LDP, you don't need multi-protocol BGP. It's a great solution if you have a small amount of networks where your VRFs are maybe 8 or less. But once you start going past that, you're either going to have a whole bunch of devices you have to configure, 100, 200 switches with that, or if you have 50 VRFs and 8 switches, it's still a lot of configuration that you have to configure. So it's typically, you see it in smaller environments or lab exams or potentially production labs where you're actually doing test labbing and stuff like that. So you get to currently use all the routing knowledge that you know now. You added, what, 1 to 2 commands to make it VRF aware. And it supports anything like multicast or QoS and all the other things that you're typically used to. So that being said, the reason I spend so much time on VRF Lite is you cannot do MPLS and multi-protocol BGP and all the stuff we're going to talk about without it. It is the fundamental of what Layer 3 VPN is built off of. Service providers do this, and enterprise networks do this. You have to know that. So that's why I spend so much time on VRF Lite, because there's a huge confusion out there that you need all these other things. You can get a lot of value out of this without even doing MPLS, but you need to know this to be able to do MPLS. So that being said, one of my most favorite topics, and why do I say it's my favorite topic? How many of this is you? Because this was me. Yeah, I feel you. I feel you. See this? Full head of hair, gone. It was a 4-head, turned into a 5-head, it just kept going. Doing MPLS. It petrified me. Quality of service petrified me. Multicast petrified me. Because they're some of the most difficult technologies because they weren't very well covered and they didn't go through the step that we just went through before, which is teaching you why it's not as hard as it looks. A lot of folks, we just make it complicated. No, we're not making it complicated. We're going to talk about what it really means. Multi-protocol label switching. You can carry any payload, IPv4, IPv6, Ethernet, ATM, frame relay. There are still ATM networks out there, right? The label is used to exchange information of routing without having to do a route table lookup, which is why service providers use it. Because if you did a route table lookup, that would mean I would have to have every one of my customers' routes in the same routing table, which I can't do because you're all using the same IP space. And there's going to be conflicts. It won't work. You can't do it. Then switching. It's literally a packet comes in, it sees this label, I know where it needs to go because every route that's in the routing table gets assigned a label automatically by enabling this. So let's talk about what it looks like in the MPLS form, right? You see we have a couple of different devices. CE devices are called customer edge routers. You might see MCE, which is managed customer edge routers. Service providers might run it for you, right? PE routers are essentially the edge of the provider network that you connect to. Now, I talk to a lot of customers, and they say they're running MPLS, but typically, they're connected to an MPLS network because their service provider's running MPLS. They just got some handoff, right? This would be if you're actually running MPLS, right? The P routers, the provider routers that are in the middle, are run by the service providers. You don't touch them, you don't see them, you don't even know they exist, unless they do not turn off a couple things like TTL forwarding and stuff like that. So when you do a trace route, sometimes you'll see the service provider core. Most of the time, they block that from you. So the customer typically peers to that PE edge router using just typical IP routing. There's no VRFs in this. This is just whatever routing protocol, static, doesn't matter. You're using that connection to that service provider. The other thing is that it exchanges those routes with the service provider, and then it essentially takes that from a service provider PE perspective and does a bunch of stuff and sends it off to any other location that you might have that's within that same VRF, right? Each customer has their own VRF. Some of them have many, right? But that means it's your customer site 1, your customer site 2 here, whatever, it could be all in the same VRF. So that's how it exchanges that information. But let's look at it from a practical perspective. There's IP routing, right? This is what the customer edge is doing, what you're doing with the service provider if you're a customer, right? You're exchanging these IP routes for loopback reachability. Now, I mentioned earlier that we're only using certain things inside the MPLS core to understand how to get to the loopback to the far end of that MPLS network, just so I can drop it back off to the other end of the network, to the other customer site. That's all that is used for. Then you'll see there's different ways to do it. OSPF, ISIS. You can do EIGRP. There's a bunch of different things you can do. Typically, you see OSPF and ISIS in major environments. When you see iBGP neighbor peering over an IGP transport, that means you either have OSPF, ISIS, or something running in the core, and you're just running a BGP over the top of it between the loopbacks, between PE1 and PE2 or PE500, because some of these service providers are huge, right? They might do a full mesh. You've heard full mesh. You'll basically anywhere to anywhere routing. It's because you have all these peers between the PE routers. It's just BGP connected to all these different PE routers. And it routes towards the BGP next hop. So let's take a look. This PE router is connected to this network of 10.2.1.1. I can see it down here, but it's easier for me to point it to you here. It tells the P router in the middle, in order for you to get a hold of me to get to this network right here, that's in this routing table, right, that is connected to my fast Ethernet 00, you need to reach my loopback IP address, which is 2.2.2.2. Again, we're only peering BGP between loopbacks. We don't care about what's going on in the core because we can't, because if we do, we'd have everybody's routes in that routing table. Then it says, okay, I'm going to tell the next PE, and there could be 50 P routers. It doesn't matter. It just keeps repeating this step all the way down. For simplicity's sake, I made it a small network, so you have just one P router in the middle. But in that case, it says, okay, well, then I'm going to send that information to PE1 and say, in order to get to 2.2.2.2 loopback, you got to come to me, which is the P router in the middle. It says, oh, that's awesome. Fantastic. That's just a typical OSPF routing update. That's any type of routing update. Works just great. Where it gets a little bit different is when we start talking about IGP versus BGP, right? So if I click this right here, we then have a BGP update that goes over the top between the loopback IP addresses that they know how to get to because of the OSPF or the ISIS that you're running in the middle. It just exchanges loopbacks between PE routers. So the BGP update then says, well, if you really want to get to 10.2.2, you can route directly towards me from PE to PE. So from 1.1.1.1, come to 2.2.2, and I'll hand off to this 10.2.1.1 network as a typical IP packet, right? So When you think that through, it's going to come through the other side, and I'm going to take this information you give me, and I'm going to strip off all this cool stuff that we're going to talk about in a second, and I'm just going to deliver it as an IP packet, because between the PE and CE, it's just regular IP routing. It does not know about anything in the core, it does not know about MPLS, doesn't know about LDP. This is where it changes. So this is what I really love about this, right? We're talking about the assignment of remote labels. So if you were to just look at this, it's the same topology, right? Everything's the same. But every single router will map a label to every route that's in its routing table, or what we like to call the MPLS LDP forwarding table. It receives information from that table, and it tells you what the outgoing interface is going to be, and then eventually it will say, I'm going to assign a label to it. This is all done downstream using something called LDP. So if I build this out, BGP update comes through, same one we just talked about, same update, right? PE wants to get to me, so I can just drop it off as regular IP traffic. But then at the same time, that's the control plane. On the data plane, it says in order to do that, use label 30. And it builds out this thing right here where it says, in order to get to me, you do label 30. So this is what LDP does. It assigns labels to every IP. So that's the separation of control plane and data plane right there. Control plane is BGP, multi-protocol BGP. Data plane is everything being layer 2 switched with those LDP labels. Same thing here. If I click this next button, there we go. It says the same thing over to PE1. Well, use label 20 to get to 2.2.2.2. And if you look, it builds out this topology table here, which is the MPLS forwarding table. So it says right here, just by looking at it, if I get any packet in with a label of 20, I don't even have to do a recursive lookup to see what the IP is. I don't care. I'm going to send it right out of this interface, and I'm going to swap the label to label number 30. And it says if it comes in with label number 30, I'm going to strip everything off, no outbound label, just IP traffic, and send it out to that destination. So that's literally how this works. So if I build this out just a little bit more, that's LDP. All it does is it says I'm going to send labels to every single IP address that's in my routing table, so I know how to communicate it over the data plane once I know that I want to talk to somebody on the other end of the control plane. So let's talk about control plane and VPN routes. You've probably heard of VPNs, VRFs, L3 VPNs, all these things. It's the exact same thing. They're called multiple names. Again, another reason why I don't really like the way that sometimes these things are taught, because it's the same thing, right? If you're in VPN A and you have one customer and you're the same business as you and you're in VPN A, it's the same thing. It's layer 3 VPN, same thing. So let's talk about why that's important. The provider edge 2 tells that provider edge 1 what the VPN label is, and you see this little V, for that network of 10.2.1.1, right? We know it exists on a CE network as regular just IP traffic, but we have to assign it a VPN label. That VPN label tells it what customer VRF to put it in. That's literally all this does. So let's show what that looks like. BGP update, same BGP update, right? Control plane. I'm just saying to the other PE router, hey, if you want to get to my IP, my customer that's sitting over here in 10.2.1.1, come to me. Packet comes in, destined for that network over here. Typical data packet. All right, it comes into the PE edge router as a typical IP packet. It then says, okay, well, what I'm going to do is I'm going to push a label onto the front of this packet, and then I'm going to use it to look at the MPLS forwarding table and see where I have to send it to that next hop. And then it also puts something on there called a transport label and a VPN label. So let's look at that. Boom. We remember what the 20 was. The 20 was saying it's just associated with this IP address, doesn't matter, I just threw a label on there. And certain platforms start at a certain number, and you can change them, and for learning purposes, you can actually change the ranges on routers to say I only want to use labels like 100 through 199, so you know exactly that it came from this router, and 200 to 299. So when you're looking at all these tables, you know that that's the route from router 6 just by looking at the way you numbered it, right? So it comes in, it pushes on this 20 label, and then there's this V. That's that VRF label. That is the VRF that is associated to VRF E, VRF O, VRF R, VRF B, whatever it is. That's the actual label for that name. So I know what VRF to stick it into for what customer. And a lot of times when you look at service provider networks, they actually name it with the customer name and then some sort of logical format so they know that it's I can't mention any customers, customer X, right? So here's what happens. Then the downstream node does a swap, which is this one in the middle. Well, that packet came in with a 20. I know if it came in with the 20, I'm going to swap it to 30 and send it out fast 00. So here's what it does. Swaps it to 30. Keeps that VPN label intact, right? Still has the original data. But now look what happened when you got from here to here. Now you're routing between the PE routers themselves, the loopbacks, the 2.2.2.2. So it took the IP packet, encapsulated it, threw it through. Now if you do this, at the very end, it's something called a pop operation. I'm going to pop those labels off so I know what VRF to stick it into so I can deliver it to that customer. And this is what happens. It goes back out the other side as just an IP packet. Doesn't matter what routing protocol, could be static, doesn't matter. That's how that all works. So when you think about MPLS and you think about labeling and you think about all these things, it's not as difficult as you would think. So that being said, this leads me to this whole BGP free core thing. We've talked about everything in that provider's core. This one has 4 routers. It could be hundreds on a service provider, however many you have in your environment. It's just running OSPF in this case, or ISIS. It does have nothing to do with anything else as far as running the customer's routes in it. But here's how it works. If you look at this, it forms between these two, this BGP relationship is called a VPN v4 IBGP neighbor adjacency, because it's the same service provider, right? So it's IBGP. It's just loopback to loopback over the top of whatever core, however big it is, country to country, doesn't matter, right? And if you look at this, it's always routing towards the next hop of whatever that BGP is. So that would be that far in PE2 in this case. So let's talk about how that works. On the provider edge router, you never see this if you're a customer connecting to that provider edge. You're just doing IP routing. But on a provider edge router, under that VPN, that address family, IPv4, VRF, whatever it may be, you're redistributing whatever that routing protocol or static that the customer is doing into that routing protocol so you can send it across the other way. By doing that, it essentially also assigns those labels using LDP to those packets. So the control plane goes over BGP, but the data can go in any form through this network you want. And in more complex networks, you might have heard of MPLS traffic engineering. You can actually go through and say, specifically, I want from this customer to go to P1, to P3, to P4, to P2, to PE2. And you set that path, right? And maybe you have a fallback and loose or strict different modes, all kinds of different stuff you can do. But it really doesn't matter because the whole idea is you're just routing BGP. Now, if you look at this, we're going to dive into multi-protocol BGP. And the reason I'm saying this, we just talked VPN v4, but we didn't explain what it is. And that's what we're going to do right now. So you see there's a VRF on this side and a VRF on that side. They have 10 dot addresses, 10.1, 10.2. Everything looks good. Pretty much what we covered a second ago. We do their redistribution, whether it's IGPs or static, from whatever the customer's router protocol is and the PE. And it says, okay, well, then now that we're doing this, the next hop for this guy is the PE1 router. Does some redistribution, same thing on the other side. Look what happens. The PE is going to receive this IPv4 update on a VRF interface via whatever means necessary and static. I didn't put static in there, but static as well. Then what's going to happen is it's going to translate it into this thing called a VPN v4 address. And I don't know if you remember, but earlier we talked about this weird thing called an RD that we did not need in VRF Lite, but you most definitely need in MPLS. And it's called a route distinguisher. Why is it a route distinguisher? Because it will take some ID, which is 64 bits, could be whatever you want to call it. Typically there's like a format, right? You might want to have your autonomous system number and whatever number represents a customer or however you want to do it, or 1:1, doesn't matter, right? It adds that 64-bit value to the front end of a 32-bit IP address if you're doing IPv4, which makes a 96-bit VPN v4 address. So there was these other things that we didn't mention yet called route targets. Route targets are saying, I want to import or export certain routes into my VRF. So maybe you do not want to import all of the routes from all the different sites to that particular VRF, or you just want to import and export everything. When you import and export everything, That's what an anywhere-to-anywhere network is. So when you hear about MPLS being anywhere-to-anywhere, it's because the customer wants to be able to reach all of their sites from anywhere, no matter what. Really good for voice and things like that, right? You want to be able to call whoever you want to call. You need reachability everywhere. So it accepts and sends all of those route targets. It also rewrites its next hop to itself. So when it says, hey, I'm sending this over to PE2, in order to get back to me to get to customer 1, I'm your next hop again. Come back this way. And then finally, it assigns that label based on that VRF, which is that V label, right? Which says, I want to put it in VRF, REO Speedwagon, or RE, whatever one you want, right? That customer's VRF. And as long as all that matches, every customer and every site can be able to talk to any other site. The provider edge router then sends a multi-protocol BGP, iBGP update to all of the other PE routers. Now, in this case, there's only 2. If there's 5,000, all of those different PE routers are going to have that VRF configured. They're going to have all of this information in it, all of the route targets, knowing exactly how to get from one end to the other. So let's take a look at what it actually looks like with this VPN v4 concept. You see on this side, we have a customer A site with the same subnet as customer B. Now we know if we routed that in our core, we're going to have some problems. So we have to do something. We service multiple customers. We have to redistribute those routes into multi-protocol BGP. But they have to be unique, and otherwise they won't be routed. So we do that by using those separate VRFs in BGP. So VRF B. You could have any VRF you want underneath that and redistribute into it. Now, the route distinguisher is prepended on the front of every prefix to make sure it looks different as it goes across, because you have 2 10.1 subnets. So what does it look like? 2 routes come in, but they look different because the 64-bit unique identifier on the front of them is 111 colon and 222 colon. But the rest of it is exactly the same. Same thing in the reverse order. This is exactly how service provider networks work. That's how you make the routes look different from customer A to customer B, just by sticking that RD on the front of whatever IP address it is, and it's sent using VPN v4. So, that being said, a couple cool things here. What if you have a bank? A lot of times there's banks that say, I don't want all my branches to be able to talk directly to each other. We have centralized services all in one headquarters. Everything has to come through the headquarters because I want to do some security monitoring. I want to do something, or maybe that's where the main internet link is to get out. This is called centralized services. So it says to import or not to import, right? If you look at it, customer site A, I'm importing all of them. Site 2, site 3, site 4, and I'm exporting myself. But if you look at C, I'm only importing one and exporting myself. The same for B and same for D, which means these spokes, these networks, they can't talk to each other. So if you picked up a phone and tried to call it, it wouldn't work. You cannot route between the different end sites. Certain folks like that for certain design security mechanisms and all kinds of things. ATMs sometimes have this kind of a configuration using things like DMVPN and all kinds of stuff. So everything has to go up into one area, because why would an ATM need to talk to another ATM? Right? But here's a key piece to this, and it's right here at the bottom. The route targets are a BGP extended community. So here we go. Exam takers, right? If you're going through and taking an exam and you are looking and you're going crazy trying to figure out why this isn't working and you can't get to where you need to go, the routes aren't showing up, and it says send BGP, or the community, send community standard. They have turned it off so you can't send route targets. But when you're flying through lab exam and it says show run router protocol BGP, and it says send community to the neighbor standard, and you're like, oh, okay, you keep going, that's why your MPLS isn't working. Because the route can't go through. It doesn't understand what a route target is because it's not sending an extended community. That's why I call this out specifically down here. Same thing for production. If you're running this in a real life production and you're wondering why one site doesn't get the routes, look at this first. Look at that first, because chances are you might have just forgot to send. Or sometimes by default, used to be send community, and now I think the iOS parses automatically to just do both. And it sends both standard and extended community, so it'll just say both. And you have an option to type in both too. So route targets dictate which VRF will receive what routes. Can be used to allow specific sites access to centralized services, like in this case, all sites report to site 1. And in this case, they won't be able to exchange routes with each other because of the route target policy. This is why if you hear route policy, route target policy, this is exactly what it means. This is also what it means when you're talking an anywhere to anywhere MPLS network versus one that is not anywhere to anywhere. This is not anywhere to anywhere because of that route target. Now there's some debugs and stuff that you can do to get into that, but that's a little bit deeper. But you can actually see some of these different things by running some of these BGP debugs. Now, let's put it all together. What does it look like? This entirety is how you would configure all of this. It's not as complex as you would think. I'm going to do VRF Lite by configuring some VRF, in this case IPv4, because I didn't call out VRF definition. I'm going to put a route distinguisher in there. Route distinguisher for whatever my private ASN I want to use, or any number I want. It could be 1:1, could be anything, right? That tells me that my routes are different from the next person's routes who are using the same IP addresses. Route target import and export, the fact that they match anywhere to anywhere. I can send and receive anything. I can get all the routes from all of my networks, as long as they match on every site. Down here, VRF2, separate VRF, could be a separate customer, right? Usually it is. In your environment, it could be a separate department, right? That you might want to, you see this a lot in tax and auditing companies too. They need to separate certain things. Similarly, but they have the same route target, and look at it, actually even matches the RD. It doesn't matter. You can change it to anything you want. 100, 60, you know, this one says 20, this one says 100. It doesn't matter. The whole difference is VRF1 and VRF2 can't match. They just have to be different because that's your route distinguisher. It will not let you configure them to be the same. It'll tell you, nah, you're already using this in VRF1. You can't use the same RD. So then you go and you say, okay, well, that's cool. I'm just going to go to the interface and put IPVRF forwarding on there and pick out whatever VRF I want to pick on. Again, if you do this in production or in a lab, it will erase your IP address off of that interface, so always do a show run on that interface first, then do that command. So then you can copy and paste it just in case, because a lot of times, even in the lab exams or even in production, you might not have the best documentation. And if you're sitting at a console and all of a sudden half of the network went down and your customers are complaining, you could be in a real bad spot. So let's look at this. Okay. Let's talk about how multi-protocol BGP works here again. We call out the routing protocol, BGP, whatever autonomous system number you want. This command is very, very important. No BGP, default IPv4 unicast. Can anybody out there shout out why that command is critical to put on? Anybody? You say it one more time? So exactly, so I'll repeat it, right? If you don't do that, all of your customers' routes are going to try to go and build an IPv4 routing table, which does what? Puts all your customers' duplicate routes in a IPv4 routing table in BGP and it won't work. You have to turn off that address family. So that's when we said VPN v4, right? You say, okay, I'm turning off IPv4 so it won't automatically try to grab all the customers' routes and stick them in a global routing table in the core of the service provider. You don't want that. And then we just do a neighbor command, typical, just like normal. This part, you have to call out address family VPN v4. This is what tells BGP, the second you say actually address family anything, it's multi-protocol BGP. If by default you don't put this command, it's just BGP. Second you say address family, could be IPv6, could be multicast, could be VPN v4, doesn't matter what it is, it just made it multi-protocol BGP, right? Neighbor, same neighbor, activate. By default, they are not activated. That neighborship is not activated. You could say neighbor, and it'll all be pre-configured, but it'll never exchange anything until you activate that neighbor, because by default, the only one that is active is IP version 4. Say that. And again, neighbor, send community extended. It has to say extended or both. If it doesn't say both or extended, it's typically this line is either missing in a lab exam or production, or it says standard. And if it says standard or it's missing, you're not going to be able to route. Your route targets don't get sent. They just don't get sent in BGP. Then in BGP, we're saying address family IPv4 VRF and the VRF name. This is on the PE edge to the customer, the CE who's running typical IP routing. In this case, they were foolish and they ran RIP. No, I was kidding. So whatever IP protocol you're routing, static, whatever it is you're routing to me is the PE router. I'm redistributing into this VRF in BGP so I could translate it into a 96-bit VPN v4 address and send it across the wire. So it come down as IPv4 in the other side. That is literally how all of that works. If you take all of these commands and follow this, you can literally build an MPLS network, just like that. And that's how everything in this lab is built. So let's show it. Let's do a little bit of exploration. Say what? Cool. So he's already run a command for us. We're good. So in this particular case, show MPLS interface. Now the reason I talk about this is what turns on LDP. You go to an interface, and you would say MPLS IP, and we'll show that in a second. That enables LDP. Now, while we're on there, and you got that highlighted, I'm glad you highlighted that. See that little thing here? LDP. Operational yes, IP yes, LDP. If those three things aren't there, all right, there'll be variations thereof. They can break things for you. We used to have something called Tag Distribution Protocol, or TDP. Every once in a while, it was in my lab exam a long time ago, you go in there, and this will say LDP, TDP, and you just you're flying. That T looks very much like that L when you're flying through an exam, right? You probably won't run into this in production because you know you're running LDP. You're not gonna be like, I'm just gonna pull out some really, really old thing and put in TDP. But if that says TDP, or it's not operational, they have broke something. There could also be an access list blocking the protocol. Was it TCP 711 or 7? We'll cover it in a minute because it's in here. There's an access list possibly blocking it, so you can't have LDP neighbor adjacencies. There's a lot of crazy things that can happen. That usually doesn't happen in a customer environment unless maybe there's a firewall in between something. So it's another thing to keep a look at, or somebody's trying to really bother you by putting in a mandatory access list. Now, we're looking at the interface. Exact same thing we said before, show IP VRF, or VRF forwarding in this case, VRF name, and then whatever the IP address is in that particular order. So, when you're looking at this stuff, you see a couple of different commands, especially in here. This one, we're doing a point-to-point interface with a VRF associated to it. Cool. MPLS, or not a VRF, this is actually in the core. MPLS IP. That is the command that enables LDP. You just go to the interface, MPLS IP, it says, okay, every route that's in my routing table, I'm giving a label. That's what enables that data plane. You have to have that facing inbound. It's inbound from the PE router. It's on a PE router inbound to the core network. None of this goes on outside facing the customer, just the VRF does. All right? Then there's a command, show MPLS LDP advertise label. Advertise label, geez. Show MPLS neighbor, I'm thinking ahead. If you do show MPLS LDP neighbor, 646, okay, so it's 646 for LDP, and it was 711, I think, for TDP or something like that. So if you look at it, these loopback IP addresses that you see on PE1 and PE2 is the source that you're making this LDP connection to between me and my next PE2 or P2 or any one of those routers. They all speak LDP, PEs and all the PE routers inside. If you get here, and it says something like, you're missing some of these neighbors, or for some reason, the loopback IP address is not the loopback that you're intending, they have changed something on you in the exam or in production, or somebody added a new higher loopback IP, and that took over as the source, and it might not be routed, or it might not be routed to the right place. So look for that. Now, I think there's one more command we're going to run right down here. Yes, okay. Show MPLS forwarding. And then if they don't have this other one, I'll have you do it manually. But show MPLS forwarding is that table I showed you where it says, I'm going to assign with LDP a label of 20. If any packet comes in, I'm going to say, if it goes out this interface, you're over here, I'm going to swap that label to 20. And sometimes you'll see 20 to 20, 16 to 16, because some of the types of routers start in the same range all the time. It just means one's local and one's been assigned to that route for the next hop. Doesn't matter, doesn't hurt anything. Where you see things like pop label or no label, that's popping the label off before it gets to that next hop. No label, you see these V's? It's going right here to a VRF. That is going directly to a customer edge router. So that's why there's no label coming off of it. It came in as 32, popping it off, sending it down. That's the command I wanted to show you down here too. So that is literally on every router. These are the separate logical lanes in the highway. It's a separate routing table. You could see all of that and how the labeling system all works just by looking at this. Now, if you run this command, show MPLS LDP discovery, right? Again, another place you can look for TDP. If that says TDP, you're in trouble. More so, if it says just XMIT for transmit or just receive, if it doesn't say both, somebody has blocked something intentionally, or there is a firewall or something that might be not intentional, blocking that to stop you from having LDP functioning. And a lot of times you'll see that in an exam, and they'll just do it in one way. It's so nice of them. And it'll just say transmit. So you're not getting, so somewhere they blocked it inbound. In production, in a lab exam, you have to look for that. Because if something like that happens, that's going to be the first indicator that somebody's broke LDP for you, and you cannot exchange labels. Any questions on some of those? Everybody's good on that? Do we have one more? One more that we're going to run. Yeah, actually, there's two more. Two more. And they're important. This is the complete configuration from the command line of what it looks like. We built it together, we talked about it, we showed it, and we showed each section. This is the full-on, top-down, every single thing that we've done today together building an MPLS network. The reason we show it to you like this is we can give you this. And you can have this file, this config file. As a matter of fact, I'm going to put this on GitHub. I have a GitHub repository up there. I didn't even think about that. I'm going to put this on GitHub. Because then you can download this, and you have you can paste it into a lab and build this right off of that, or you can use dcloud and do the exact same lab, right? But every single thing that we've talked about today is built out in a fully functioning network, running all the routing protocols. So it basically acts like you are a service provider, because you have BGP, you're redistributing EIGRP and RIP and OSPF and all these different routing protocols. It's all in one config file that you can take with you, right? It's very important. And then this command down here I would love to pick on. Thank you for going to it. This says show IP BGP VPN v4 all. What does that mean? Can anybody tell me what that means? Anybody? It's okay, you can shout out. Yes.
It should be the provider's routing table.
It is the routing table for the provider, correct. What else does it mean? With that word right there. Right. It's IP version 4 only. Yes, sir. I'm sorry, say it again? VRF routes, exactly. These are the routes that BGP is exchanging. And this is cool because it actually tells you for the name VRF, we named the VRF in this particular case to keep it simple. These are the routes that are being exchanged in BGP with this route distinguisher to make them look different, right? Could be, like I said, 65,000, could be 1:1, in this case it's 5:1, 7:1, doesn't matter. We use these to show you that they're differentiated into different pieces here, right? The other thing that also means, can you scroll up for just a second again? Just to actual show the command itself. And right there. So, if you are running VRF definition, multi-address family BGP, which is very common, right? Multi-address family VRFs, multi-address family BGP, it would be show BGP VPN v4 unicast all, right? And there's a summary command. Remember show IP BGP summary? And you just see the summary? It's the same exact thing. It's either all or summary. All shows you all of the different VRFs, right? And I think if you scroll down, summary's in there. Maybe not. But what it does is that would be where it just says your neighbor, if it's hopefully how many prefixes are received all the way to the right versus saying like active or open or down or something like that. Just show IP BGP summary will show you your IP BGP peer. If you do show BGP VPN v4 unicast summary or all summary, all will show you all VRFs. So if you have more than one VRF in your service provider, you want to look at all of them at once, or you could actually go out and say, you can actually go out and pick on specifically just one VRF instead of saying all, say VRF name, and just look at that particular table, right? Yep. Yes, sir.
I would actually advise anybody playing with this to stop using show IP BGP and start straight with show BGP, because show IP BGP is the free MPBGP stuff and doesn't contain all the information. So show BGP is the way.
Absolutely. So what this gentleman just said is something that, there's a reason I teach it in this way, but you got a great point. Train yourself to do it this way without doing IP first, right? It'll still work, right? Because at some point, maybe you'll get to using IP version 6, and then you'll have to use these commands, right? If you do show IP, that means, and the reason it's like this is because almost every customer out there is still running IPv4. The update to that would be is if you can train yourself to use the show BGP v4 commands, right? Instead of saying IP, it'll still show you the same output, but now you already know what by heart to configure when you do to go to IP version 6. So that's a very good point. Train yourself to use that command if you want, especially in an exam. Maybe you might see, they say, well, what command will show the routing table in a multi-address family? You don't want to do IP. You want to do show BGP VPN v4 unicast, right? So these are the different type of commands that you would run yourself into. And of course, did it work for you?
What?
That command?
The last script?
Yeah, last script. And now, this is the proof. We're going to ping from CE to CE across the MPLS network we just created to make sure that it actually works. Boop. Those two same IP addresses that we saw on the far end that came across in that particular instance. You have end-to-end reachability across a service provider network, which is running MPLS, whether you put it in your enterprise or it's technically still like a service provider you just built. And you have end-to-end reachability using straight IP traffic from each CE to each CE across an MPLS network that we just created. So, that being said, if we can go back to the slides real quick, we're going to summarize it all. CE edge routers, customer edge, MCE, managed customer edge. Maybe the service provider manages it for you. You're sending these routes via IP, either static, RIP, EIGRP, BGP, OSPF. They're unlabeled IP packets, just like you saw pinging from CE to CE. What happens is then you get to the PE router. This is where your MPLS edge actually starts. We're saying we have these VRFs now facing these customers so we can make sure we can segment that traffic into separate lanes on the highway. Then we're going to take that information and we're going to forward it to the P routers on the data plane using those LDP labels that we talked about. That's where your actual data goes. The control plane, remember, goes over the top using BGP. You can use IP or IGPs or BGP to communicate from the CE router to the PE router, and static. I've seen it done with static. Not super scalable, but in the lab, sure, you might be able to do that. It might be an option, right? What that does is it distributes this VPN information all the way through multi-protocol BGP from one end to another by saying, the second you come in with this, what am I going to do? I'm going to assign a label using LDP, and I'm going to stick a VPN label on it so I know when it gets to the other side what customer I have to drop it off in, what VRF I have to drop it off in. Again, these route targets that we talked about are extended communities. The VPN v4 address is a 96-bit address, which just takes that 64-bit RD, which says that my traffic is different from the next customer's traffic, and sticks it on the front of whatever IP address it is, sends it across because it's unique, right? It will not let you can't make the mistake of configuring the same route distinguisher on two VRFs. It won't let you do it, which is a good thing. And then finally, what it does is it pushes those labels onto those incoming IP packets. Maybe it's that 20 we talked about, and it sends it on its way to the provider core. In this particular case, these P routers are the core that are running MPLS LDP. Now, on this interface facing the P routers, and this interface facing the P routers, and on every P router interface that has any link, the command MPLS IP is on that interface, because that's what turns on LDP to exchange those labels back and forth through the core. Similarly to how we talked about VRF Lite, layer 2 802.1q trunking, having to make sure that that information is at every single hop all the way along, otherwise you don't have reachability. If that service provider doesn't have MPLS IP on one interface and that traffic decides to go there, it's not going to get through. You're going to have some issues with routing. Now, the other thing it says, you do not have to run BGP on this because it is just an exchange of the loopback information on PE1 and PE2. So it's just OSPF, ISIS, whatever you want to run All you're doing is exchanging the loop back to the PEs so you can build that BGP tunnel across to make the VPN v4. Has no knowledge of VPNs, doesn't know anything, has no idea about it. All it does is does something called swap and popping of labels based on the packet and the LDP label you put on it. It does not go through and dig down deep to figure out what that IP address is or route is, because that would be a recursive route lookup. And at the scale of some of these service providers, that would be a problem, right? Secondly, it doesn't know about what that IP address is. There's nothing to recursive look up. Because in order to do that, I would have to have all of my customers' routes in my core, and we can't do that because we'd have duplicates. Now, some closing thoughts. Everything we talked about, if you break it up into small, manageable chunks, it's fairly easy to follow. And you'll have access to this deck. We can give you, I'm going to put this thing on GitHub because I just thought that right now. I've been doing this for so long. This would be a great idea. Put it on GitHub. Break it into small, manageable chunks to accelerate your learning. VRF Lite, most folks are like, oh, it's just VRF. It's just VRF. It's VRF Lite. VRF Lite and VRF aware routing is fundamental to MPLS. It won't work without it. You can't do it without it. That's how you actually do the routing, and it's only 1 or 2 commands to any routing protocol to make those routing protocols VRF aware. So break it down, and then it helps to build on. Leverage the current routing protocol knowledge you already have. Any routing, you can see we even went back as far as RIP. Some customers still run it, right? Bless you. So if you're in that instance, it doesn't matter what routing protocol you use. It's usually going to be something like address family, IPv4, VRF name, or you're going to be an OSPF and you're going to say router OSPF to VRF name, or you're going to be an EIGRP, we're going to say the exact same thing, address family, IPv4, VRF name, but then you have to remember in that VRF to put your autonomous system number because you just ripped it out of the global routing table and you won't be able to do a peering adjacency unless you do that. If a route, this is for everybody in production and anybody going for any certification, if there's a route that is not present on the customer edge routers, right, for whatever reason, check the route target, import and export. It could be misconfigured with a different number. A lot of times you'll go in there and it might say 111:11 is the one that they decided to choose for their route targets. And then you'll go in one router, it's 111:111. And it's off by 1 digit, and boy, do they look the same when you're in a CCI or lab exam flying through things. You're off by 1 digit, your vision starts to go. Look for that. Also understand that there could be issues between the BGP redistribution between the routing protocol that the customer is using and what you're trying to put into that VRF, right? So if you did redistribution, maybe you did it in one way, you forgot to do it on the other side. That's very possible, it happens all the time. And then again, if you're having reachability issues, this is more data plane. This is where you're checking to see you have the routes, they're present. I can't get to it for some reason. I just can't ping it. I can't figure out why it's not working, right? There's 2 pieces here. Thank you, I agree. I thought it was fantastic. No, I'm just kidding. The idea there is the MPLS configuration could be broken. LDP could be broken. An access list could be broken blocking LDP, right? The data plane might not be working because of some of the things that somebody has done to you or a misconfiguration. TDP could be accidentally running instead of LDP. Firewall in between could be blocking one port 646 for TCP or 711 for TDP or whatever, right? You have to look at those things. The other thing is, on the PE devices, when you're doing anything from a troubleshooting and monitoring perspective, you're living in a VRF world, just like Madonna said. Anyway. The idea here is that you have to ping VRF, trace VRF, show IP route VRF, everything VRF, because you're not looking at the global routing table anymore. You're looking at that particular separate lane on a highway. Have fun. It's a journey. It's definitely not a destination. So that hopefully concludes me to say, what does MPLS stand for now, right? It's something that you can master, share, practice, and learn, right? It has nothing to do with the most painful thing to learn and study. That being said, does anybody have any questions? Does anybody have time to fill out some surveys and enter themselves in to win a cool shirt? Please feel free to do so. I will be here. Dustin will be here. Thank you all for attending. Hopefully this was fun. Hopefully this was different. Hopefully we took something that was complex and made it a lot easier. And I really appreciate everybody coming. And if anybody has any questions, I'll be here, and connect with me online. I look for the GitHub repository under my name. You'll see it. I'm going to start. I think I might do that tonight. You could download all this. And Dustin, if they wanted to get access to this lab somehow, I know it's not fully published yet, how do we work on getting folks access to this so they can practice it?
So go ahead, join the WebEx. Go join the WebEx space, and then just let us know that you're interested, and we'll give you access. We'll give you an environment.
So you'll be able to do it. All right. So thank you all so very much. And again, if you want to continue your education, you know, there's a lot of other cool things going on all for the rest of the day tomorrow, but mostly tomorrow for learning sessions and stuff like that. So I believe the World of Solutions closes today, but tomorrow you can still do a lot of different things. And there's the on-demand library where you can watch this talk in many different countries and states. And hopefully you enjoy your Cisco Live. Thank you so much for coming. I greatly appreciate you. And thank you, Dustin, for running all this and making sure that everything worked. I appreciate you as well. All right, that's it for me. Thank you so much. Thank you all.